Everybody, Mr. Bucko here with a couple of examples from section 4.7 where we are solving for a variable in terms of other variables. So we're going to use the same process as we've used in the past for solving equations. The only difference is our answers are going to look a little bit differently. So got a first example here where we have the equation for the circumference of a circle is c circumference equals 2 times pi times the radius, where r is the radius. We're going to solve for r. So kind of without knowing even what this equation even means, we can answer this question solving for r by solving for the variable r by getting r alone. And when you look at this equation here, we see we have c equals 2 pi r. r is on the right hand side of the equation, and we want to isolate r. We want to solve for r, meaning r equals what? So when we look on the right hand side, we see a 2 pi r, and we're multiplying all these things together. So we're taking 2 times pi, which is a number like 6.28 to estimate, and we're multiplying that by r. And we want to undo that multiplication to isolate r. So what we're going to do to both sides here is divide both sides by 2 pi to get r alone, because the 2 pi divided on the right hand side will cancel out, and we have c divided by 2 pi on the left side, and we can't do c divided by 2 pi, so we just leave it as c divided by 2 pi, and our resulting equation is c over 2 pi is equal to r. So once again, this equation doesn't look any better than what we started with, but it is solved for in terms of a different variable. So if we knew the circumference, we could plug in the circumference here and find out the radius. Whereas if we had c equals 2 pi r, if we knew the radius, we could easily find the circumference, and just by the way that that equation is set up. So these two things say the exact same thing. The only difference is they're solved for in terms of a different variable. So just kind of whichever information you have, one of these is going to be more useful than the other, but they say the exact same thing. Another example, something that we'll see a lot of as the year goes on, especially in chapter 6, we have 2x plus 8y equals 16, and we want to solve for I. We want to isolate y. So we look at the equation, we see that y is on the left hand side of the equation here, and there's a 2x plus 8y there. We're going to work with this 2x first. We don't want any x's there, we want nothing. We want y equals, so these two x's have to go, all of them. So what we're going to do to both sides is subtract 2x, because 2x minus 2x is 0, and notice I do that to the right hand side, 16 minus 2x. As a result of that, we get 8y equals 16 minus 2x. We cannot do 16 minus 2x because they are not like terms, so when we see 16 minus 2x, we just leave it as 16 minus 2x. The 8y is from right here, and the 2x's are gone. We're not quite done yet because we have 8y, so we want to get rid of this 8, and we are multiplying 8 and y together. So what we're going to do to both sides is divide by 8. By dividing by 8, these 8's cancel out. And then we have 16 minus 2x divided by 8, which is what just showed up here. So y equals 16 minus 2x divided by 8. And for all intents and purposes, we can stop here. We have solved for y. y equals 16 minus 2x divided by 8. But we can simplify this one step further and say that y equals 2 minus 1/4 x. Where does the 2 come from? 16 divided by 8. Where does the 1/4 come from? Negative 2 over 8 can be reduced to negative 1 over 4. So we have negative 1/4 x. So now we have solved this equation in terms of y. Again, does it look any simpler than what it started with? No, not really. And in some cases, it's not more simple. But we have used our algebra processes to get y alone and solve for y. So now if we knew what x was, it would be very easy to find out what the resulting y would be. Whereas if we knew what x was here, it's going to be a little bit more complicated. We could still do it, but it's just going to not be as straightforward and easy as if we knew what x was here. Another one, solve for w. Kind of like the 2 pi r equation. We have 3 times x times w equals 9. So we're multiplying all these things together, and we want to get w alone. So we're going to divide by 3x. We're multiplying 3x by w. So if we divide by 3x, these 3x's cancel out, because 3x divided by 3x is 1, leaving us with 1w. On the right hand side, we have 9 divided by 3x. So we have 9 equals, or w equals 9 over 3x. 9 over 3 can be simplified. And again, for all intents and purposes, we could stop here because we have solved for w, but we can simplify 9 over 3. Simplify 9 over 3 to 3 over 1. So this can be simplified further to w equals 3 over 1x. And notice I didn't write the 1 here because it's unnecessary to write a 1 in front of a variable, because if we have a variable, there's kind of that imaginary 1 down there. So a couple examples on section 4.7. Got a couple more coming, so look out for those.